So today's lesson is the first lesson in chapter 3 on plane geometry. So because geometry often involves angles, there are a few details around angles that we need to be clear of before we begin. And the first is labeling. So let's say I'm talking about the angle formed between these two green lines here. There are two different ways that we can label an angle. So let's say I call the end of this line here A, and the corner here, the vertex, as B, and then the end over here as C. So I can label angle B as simply angle B using the symbol that looks like an angle, or I can label it as though I'm starting over here, drawing a line to B, and then finishing off at C, and those together join to make angle B. So I can also call angle B angle ABC. Notice here that the actual angle that I'm talking about is angle B, and it's in the center of the three letters. So it's almost like I'm A to B to C, just forming that angle. That may come up. And so it's important to know how to interpret what that labeling means. So it's also important for you to understand some basic terminology in the unit. So the first one is supplementary angles. So supplementary angles are angles that will add up to 180 degrees, right? So the way to identify that you're dealing with a situation that involves supplementary angles is if you see a straight line. So, for instance, here I see a straight line, and that straight line, in order to make that, I had to create an angle of 180 degrees. So this is 180 degrees on this side, but I also have 180 degrees if I consider the entirety or the whole of the other side of that. So really, if I were to label this angle on the left here as angle X, and I were to label the angle on the right as angle Y, then I know that angle X plus angle Y will give me 180 degrees. Okay? So I'm going to show you what I mean through an example. So some of you may want to rely on algebra to help you through some of the more difficult problems, but if simply problem solving your way through it, thinking and reasoning works for you, then that's great as well. Okay, so whenever you're looking at a geometry question involving angles, it helps you to be able to identify if there is a straight line, because often as soon as you see a straight line, then you may be looking at a case of supplementary angles. And so for me, I can see that I have a straight line here, and I know that the angles that make up that straight line have to add up to 180 degrees. Okay, so one way to show this, to represent this algebraically, if you want to, is to think of it as, I know that angle X plus the 130 degrees have to add up to 180 degrees. Now I can also reason and just say, well, my unknown angle, X, has to be the whole angle of 180 degrees, that whole supplementary angle, and I'm going to take away the 130 degrees. Either way that works, and I know that my missing angle X happens to be 50 degrees. So the question in this case also says that I need to justify it. Okay, so I need to justify that, and so the way that I'm going to justify that is in brackets just beside. I'm going to let the reader know that the way that I solved that was by using supplementary angles. So the next important term that you need to know moving forward is complementary angles. So complementary angles are angles that add up to 90 degrees. So I want you to be sure that you're in fact looking at a case where the angle is complementary. And the way that we usually indicate that the angle is a right angle is by seeing this little box. So unless there's a little box there, you can't really be sure that it's 100% a 90-degree angle. Okay, so just because it may look like it's a right angle doesn't mean it actually is. If we're using proper format, then the box needs to be there. So the box being there actually is a huge clue, because it tells you that you do have a complementary angle, and that will help you to solve some unknowns. So, for example, if I know that this little angle in here is a certain amount, and I know that I need to find out the second angle, well, I know that in this case, x plus y, they both have to add up to that 90 degrees. Okay, so those are complementary angles. So students often struggle with these words, remembering which is the one that's supposed to be 90 degrees and which is the one that's supposed to be 180 degrees. So the way that I worked it out for myself is I remembered that, C comes before S in the alphabet. And so C coming before S, the complementary one is the one that is the smaller value, and supplementary is the 180. So, C comes before S, just like 90 comes back before 180. So if that helps you to remember which is which, then I hope that you can use that. So in this example, I can see clearly that I have a case of complementary angles. And what's telling me that is that box there. That box is a hint that I have a right angle to work with, and that might help me figure out this question. So modeling this using algebra may work for you, and I'm going to start with that. So I know that these two angles, angle x and angle and the 62 degrees, are complementary, and they add up to 90 degrees. So really, all that I'm doing is I'm saying, well, the value for that unknown angle x is going to be 90 degrees, take away 62 degrees, and that will give me 28 degrees. So just remember, you want to use good format. The degrees is like a unit here, and so it's important to not just write out 28, but 28 degrees. This question also asks me to justify it, and so because I'm asked to justify, I'm going to write out that this is a case of complementary angles. Two other points before we do our last couple of examples for this section of your workbook. We need to consider when lines intersect. So what do I mean by that? Well, lines intersecting means that they cross and meet at a point. So in both the blue intersecting lines and the red ones, I can see that they clearly make an X, and so they intersect. So the first point I want to make is that opposite angles are equal. What do I mean by that? Well, I'm talking about the angles that are directly across from each other. They're the ones that are equal. So, sometimes in math we'll symbolize that they're equal by using the same little character. So, for instance, I've indicated that these vertically opposite angles are equal by writing in that colored in dot. And maybe another way to talk about angles is to say, well, here's a different symbol, and I'm going to indicate that they're equal because they're vertically opposite by writing that little symbol X. Another way algebraically to say this, I'm just going to label these angles as A, B, C, D. Another way to indicate that is to say, well, I know that A is equal to C, and I also know that B is equal to D. Okay? And all of that is called opposite angle theorem, so we can write OA in brackets if we needed to justify. So that's the first little bit. The second little bit is that adjacent angles, or angles that are next to each other, are supplementary. So again, even though these lines are intersecting, right, I still need to remember that each line on its own is a straight line, so there's some supplementary angles there, right? And so I'm going to go through a proof of opposite angle theorem by using supplementary angles. So let's say, for instance, that I know that this angle right here is 120 degrees, right? Well, if I consider right here this to be a straight line, then I know that 120 degrees plus this unknown angle right in here, they have to add up to 180 degrees. So I know that. So knowing that, I've made the numbers quite simple here. That makes this unknown angle here 60 degrees, right? So I'm going to get rid of this little bit, this little writing here for a second. Now I want us to consider a different straight line. Well, I want this straight line right here. So when I look at this, I can also see that there is a supplementary angle, two more supplementary angles, right? I have a supplementary angle right here that I'm going to talk about first. So I'm going to, I know that the 60 degrees plus this other angle right in here have to add up again to 180 degrees. And so I'm going to end up with another angle at 120 degrees. So notice how my vertically opposite angles in this case end up being equal. Okay, there's one proof. And I can use the same logic using my supplementary angle theorem to say, well, if here's another straight line, and I'm going to go this way, and that will help me to fill in that this other unknown angle here is 60 degrees as well. So we have a bunch of opposite angles, and those vertically opposite angles are equal to each other. So here are a couple of examples for you to try out on your own. Pause the video, try them, and then once you've tried it, continue with the video so that you can see whether you are on the right track. All right, let me go through this now. So the good thing about this geometry is that there are multiple ways to figure out some unknowns, right? And it all depends on how you look at it. And often each of the solutions is perfectly okay. So for me, I try to highlight. Highlighters may work for you in order to help you solve this. I see that I have intersecting lines, and so I'm going to highlight my intersecting lines because I know that vertically opposite angles have to be equal. And so here's an angle, x is opposite this 55, and so that's telling me right off the bat that x is equal to 55 degrees. And if I want to justify that, I'm going to say, well, that's because of opposite angles. Okay, so there I have x. Now, as you go, it may also be helpful for you to write in the values, write in your diagram of the things that you know. So I know that x is 55 degrees. Okay, so I've done what I can with opposite angles. It looks like y and z are opposite each other. So if I find out what one of them is, I can get the other. But I'm done with the intersecting lines, so I need to maybe look at some other avenues. I don't see a 90-degree angle here, so the only other option for me so far is to look for a straight line. So I'm going to use this straight line right here. When I look at that, I can see that this angle 55 degrees and y together are supplementary. They have to add up to 180 degrees. So I'm going to say that I know that y plus 55 degrees has to add up to 180 degrees. So doing that subtraction, I'm going to find out the value of my angle y. So 180 minus 50 is 130 minus 5 more gives me 125 degrees. And so we've solved for y. I'm going to put that right in my diagram here and see if that helps. So now I know that y is 125 degrees. And you may remember a couple minutes ago that I mentioned that if I had y, I could get z because they, of course, are vertically opposite each other. I'm going to write down my justification for y. That was supplementary angles. And now I need to find z. Well, z is simply equal to 125 degrees, and I know that because of opposite angles. There are other ways that I could have figured out z, but that will work. I'm going to set you up with a different example here that I want you to try on your own and then check. Okay, I'm going to quickly go through this with you. So when I look at this, I can see that I have some intersecting lines. And so right away, that tells me that z is equal to 40 degrees. Secondly, I can tell that I have a straight line right here, and that x plus 40 degrees plus 25 degrees will give me 180 degrees because of that supplementary angle theorem. Okay, and when I solve for that, I'm going to get a value. So 180 minus 40 is 140, minus 20 will give me 120, minus 5 more will give me 115 degrees for that angle, for x. Now I simply have to find y, and there are different ways that I can find y. But what I'm going to do is I'm actually going to use that same straight line, and I'm going to remind myself that I know that z is 40, and so I know that y plus z has to be equal to 180 degrees. That's what's telling me that I know what z is, and y plus 40 degrees has to give me the 180 degrees. So angle y is going to be equal to 140 degrees. And so I'm done. I've highlighted some homework for you to try out in your workbook. Make sure that you are able to do the questions that are involved, numbers 1 to 8. And they do get difficult. Don't give up. Just try your best. And remember that the worksheet solutions or the workbook solutions are online.